Okay, my name's Gil Kirkpatrick. I'm the CTO at VUDS Identity Solutions. We're a small software company based in Australia, and we build identity infrastructure products for government agencies, large enterprises, and a lot of public service entities like state governments, hospitals, that sort of thing. And today I'm going to talk a little bit about the problem with passwords and two relatively newish technologies for addressing them. So first off, let me just put this up here. What would you guess is the common denominator here? Just raise your hand if you have an idea. Yes?
We're on the cloud.
Well, I think everybody's pretty much in the cloud in some sense or another right now, but that's a guess, but not the right one. Okay, all of these companies were hacked in 2018 to the tune of 1.5 billion accounts. And when I spent a little time researching the increases in the compromise of identity information overall, and I was kind of shocked at the numbers. I knew it was bad, but I didn't realize it was this bad. And 80% of all of the breaches overall, not just in the top 20%, are due to stolen credentials of some sort or another. So stolen credentials were a factor in exfiltrating that identity information. And just last night, I read another paper that came out. It was by a company that, instead of looking at breach notifications, which is where this data comes from, is actually looking at the identity information that's available for sale on the, quote, dark web. And they have a slightly different picture of the situation. So in 2018, there were over 12,000 separate identified breaches that exposed identity information, adding 3.6 billion new identity records to what's available for sale. So you can actually go out and buy these identities. It includes names and phone numbers and credit card information and email addresses and passwords and you name it, which is a pretty substantial increase over 2017. But probably more notable is the fact that the average breach size has gone way down. So what's happening now is where the large social identity vendors like Facebook and Twitter and those sorts of things were getting hacked earlier. Now it's sort of the mid to larger enterprises that are getting hacked. So the total number of breaches is going up, the number of identities per breach is going down, and the overall total, the grand total, is there are 14 billion identity records available for sale in case you want some. That is really, really bad. And one of the fundamental reasons for this is the fact that we are so dependent on usernames and passwords. So what's the approach? So there's really two approaches, one of which you're certainly going to be familiar with, which is single sign-on. If you run Active Directory, you have at least some amount of single sign-on in your environment. But as you incorporate cloud applications, you need to extend that single sign-on to the cloud as well. The problem is that you can't have a separate set of credentials for every single application for every single user, because people can't live with that. It's just awful. And the second thing to do is to get rid of passwords entirely. And there's a new set of standards that have been ratified just in the last few months called FIDO 2 and WebAuthN, which actually, I think, gives us a chance to start removing passwords from the equation. And I'll spend a little bit of time on single sign-on and OpenID Connect, and a little bit more time on FIDO 2 and what all that means. So just out of curiosity, has anybody here, first off, has anybody here heard of FIDO? A few of you, great, okay. And has anybody here deployed Windows Hello in an enterprise environment? Actually deployed or working on deploying? Working on it. Okay, that's good to know. I've been paying attention to FIDO for a few years now, and the recent changes with FIDO 2 and WebAuthN I think are really, really encouraging, but it's new. So first off, I'll talk about OpenID Connect. This is a newish standard for implementing authentication for web-based applications and single sign-on as well. It's based on OAuth 2, which you're probably all familiar with to some degree or another. And probably the biggest improvement over earlier technologies is that it's easy to implement. It's at the point now where if I'm an application developer, I'm building a web application of some sort, I can literally import a couple of modules, tweak my code a little bit, and I have OpenID Connect, which means I get single sign-on and all of that for free. If I'm a developer, I don't have to really understand anything. I just download the code. It looks like it works, and I'm all good. So essentially, OpenID Connect is SAML for millennials. They don't really have to understand it. They don't have to get it, but it seems to work. Any millennials in the audience? Sorry. So as I said, OpenID Connect is based on OAuth 2, and it essentially provides 3 endpoints. So as an identity provider, the 3 endpoints. The authorization endpoint, which produces an access token, which really is just OAuth. The token endpoint, which can provide an identity token, which is essentially a record of the authentication event. So it tells you that somebody actually authenticated. OAuth doesn't tell you that anybody authenticated, it just gives you permission to stuff. And then finally, there's a third endpoint called the user info endpoint. And this is a little bit like a directory endpoint, except it doesn't give you query ability, really. It just lets you say, give me all the information about this particular user. So for standing up a web application, this is really what you need to get going. You can get information about the user. You can find out what you have access to because the user has granted you access. And you can determine that he's authenticated and in what way he's authenticated. So it gives you everything you need as a web developer to implement single sign-on and delegated authentication. This is the flow. It's a little bit of an eye chart. I apologize. I stole it off the web. The basic idea is that when an application gets a request from a browser that's unauthenticated, the application is configured to redirect it to an identity provider. The identity provider then asks the user to input their credentials and provide authorization. They authenticate. The identity provider provides an access token and an ID token, redirects it back to the application. It looks at the token and does all the stuff, and the application at that point can either use the token or there's an extra step involved where it exchanges a code for a token, depends on the flow. And so on. So the application basically gets authentication information that way. It's pretty straightforward. It looks a lot like SAML, but way easier and way less expensive on the network to implement. Did anybody here actually use OpenID Connect in their environment? Couple? All right. I mean, we've certainly moved to focusing on OpenID Connect as the primary means for integrating applications at the identity layer. And it works pretty well. It's not the most secure thing in the world, but it's way better than usernames and passwords for every single application. But the problem is this doesn't actually get rid of passwords, because pretty much every OpenID Connect environment depends on passwords, and users can't deal with passwords. We know that from history. I mean, I looked at I use Password Safe as a password vault for my own passwords. I've got like 260 passwords in it. I can't deal with that. And I wanted to throw in here this idea about two-factor authentication. How many people here use 2FA in their environment for some things? A few of you. Can you imagine using that for all of your applications? That would be, I think, pretty miserable. And they're not as secure as you'd like them to be. They're hard to deal with because you have to register them and issue them to people and manage them. If you're using the applications on your phone, those are sensitive to time sync problems. The user experience is just not very seamless. It's a whole extra step that you have to go through. Which brings me to FIDO. So FIDO is, the FIDO Alliance is a group of tech companies that got together, I want to say about 7 or 8 years ago, to improve the authentication process on the internet. And they came out with two protocols called UAF and U2F, so Universal Authentication Framework and Universal Second Factor. And the idea was to provide either an application on a phone or a little token, a USB token, that you can use to simplify the authentication process. But the underlying technology is the really cool part, because these things are, in a sense, they're actually like miniature certificate authorities. So for every single application that a user uses, this device will mint a public-private key pair and assign it to that application. So instead of having passwords that you type in, you actually are using public-private keys for each separate application. So as a technical approach, I really like that a lot, because you get rid of passwords, and PKI is relatively secure as these things go. But it takes the management issue for the user out of the equation. It's not like he has to run a CA. All he has to do is like touch the key when he needs a new key pair. So the user's not even aware of what's going on underneath the covers. It's pretty neat that way. So let me do a little review of the terminology, because there's quite a bit, and it was actually a little confusing with the new FIDO 2 protocols. So FIDO is Fast Identity Online. That's the organization and the set of standards. The two earlier standards, UAF and U2F. U2F is actually continuing forward and is now called CTAP1 for Client to Authenticator Protocol number 1. And the new set of protocols, which are under the umbrella of FIDO 2, include CTAP1, CTAP2, and WebAuthN. And WebAuthN is the thing that actually makes this all work. WebAuthN was ratified by the W3C, I think about a month ago. And it specifies a bunch of extensions to JavaScript implementations in browsers to allow FIDO authenticators to work. So it's now, from an application development perspective, it's now possible to incorporate FIDO technology, so this public-private key technology for authentication, on any modern browser with a minimum of effort. So as far as a high-level view, this is sort of what it looks like. You have the web application here. I'm not going to talk about things that aren't web applications. We'll just stick with web applications. And it communicates with the browser running on the client, which has access to these new APIs in the JavaScript implementation. When the application puts up a login form, and this thing might be an identity provider, it isn't necessarily a separate application, that login form will call these JavaScript APIs to do the authentication process locally. The other cool thing about the FIDO approach is that anything that's used to access the public-private key on the device is kept local to this machine. So usually what happens is you do an eyeball scan, or you put your thumbprint on the thumbprint reader, or you tap a device, or put in a PIN, for instance. That's how you unlock the public-private key for the application to authenticate you. But that information never actually leaves the client. Okay, so that information, the biometric, for instance, stays on the machine, never goes on the network at all. The only thing that goes on the network is verification that the client has the private key. Where was I? Okay, so the browser has access to these FIDO APIs, or the WebAuthN APIs, and through the operating system can access either the onboard trust module, the TPM, or an external device, either through Bluetooth or through NFC or through a USB thing. So you can, as an example, take a phone and wave it at your PC to authenticate as a second factor. Or you can tap the USB key. I've got a little Yubico USB thing on my laptop. It just has a little copper thing sticking out the edge. I just tap it to show that I'm present. So a few more terms to go over. The authenticator is the device that actually mints the key pair and can store them. And it has to respond to those APIs, those new WebAuthN APIs. Attestation is the process of the authenticator essentially representing itself to the application. So it provides a signed package of information that includes the UUID, what kind of capabilities it has, the brand name, that sort of thing. That's all encrypted and signed and then sent to the application so it can keep it for later. An assertion is made when you authenticate. So when the application requests the user to authenticate, the device will generate an assertion, and that has a particular format that then gets sent to the application for verification. The relying party, which is the application itself, or it might be the identity provider in this equation, so whoever it is that's consuming the authentication is the relying party. The relying party identifier is essentially the host name and URL path to the relying party. So it might be foo.com/identity or foo.com login or something like that will be the relying party ID. And that's used to keep all of the credentials on the device separate. So remember when I said these public-private key pairs are assigned to each application. That's how it identifies the application, is by the URL. And then there are two user tests that FIDO supports. User presence, which just means the user has to do something to show that he's actually there. So it might be tapping the key or something like that. And user verification, which is some sort of process to provide a second factor. It might be a PIN or it might be a thumbprint or anything like that. And different devices will support different modes of authentication. Okay, let me stop real quick and just see if there are any questions. I've gone over a lot of terminology, but that'll set you up for the rest of it. Any? Okay. So there are a bunch of different kinds of authenticators. They can run from being trivial mechanical implementations to things that are fairly sophisticated. The big differentiating factors are, or the big differentiating factor, is it built into the machine or is it something it's external? So my desktop at home has a TPM, so that's my authentication device for FIDO purposes. For this laptop, I've got a little USB key that sticks in the USB port. And I can use that on different machines if I want. But the keys, the private keys, are actually on that little USB thing. And this is how the process works. There's really two phases. One's registration. So one of the cool things about FIDO, the FIDO approach, is that users can register their devices themselves. You don't have to go through some central authority to do that. And then you can just buy these things off of Amazon and have your users start using them. So the web application will put up a form that asks for the user to register. At that point, the user will get a dialog, and this actually comes from the browser. So this comes from the browser. The new APIs in the browser will put up a form that says, select the authenticator you want. If there's already one that's fixed in the machine and there's no options, then it just assumes that that's the one you want. Otherwise, it'll say, insert your USB key or use the TPM or whatever it is. Then the user enters in their account, so their username, selects the device, and then they go through some gesture to approve the registration. And at that point, the FIDO device mints a new key pair and makes that attestation record, which contains all the information about the authenticator, and incorporates the public key in that and sends it back up through the browser, back up to the web application. So the application now has the account and information about the authenticator and the public key. Okay? And it'll store it in its database along with the user ID. But there's no password. So this is the cool thing. All it has is a public key. Now, when the authentication process happens, the web application will put up a login form, and it will say, it will basically invoke the WebAuthN APIs in the JavaScript in the browser, and it will then pop up a dialog that says, insert your device if it's not already inserted, or select from a list of potential devices. And depending on what the application wants, if it wants just user presence or if it wants user verification, the browser will then say, enter in your PIN, or you put your thumb on the USB key, or tap the blinking USB device, which is what it does on mine, because the application I have just wants to know that I'm here. So I just tap the thing. It then signs an assertion, an authentication assertion using the private key and a challenge that comes from the web application, sends that all back to the application. The application then verifies the signature, makes sure the challenge is correct, and at that point it's authenticated the user. So no passwords involved. All the user had to do was tap the USB thing on his laptop or desktop, and because there are no passwords, there's nothing to be compromised. The only thing that goes out on the network is an encrypted public key. The private key never leaves the device. So that's all very solid from a security standpoint. There's nothing sort of wandering around on the network that might be compromised. So there are two forms of user interaction with the physical device. Actually, there can be several. Just tapping on it, all that's really designed to provide is verification that a user is there. So that doesn't actually provide much in the way of dealing with a stolen laptop. But if you have a device that, say, takes a thumbprint or requires a PIN, then that does, because you can't get it without that second factor, essentially.
Because none of those little YubiKeys are tiny, and so I don't
Right.
see anybody like taking them with them on their keychain.
Right.
So they're going to keep them in the laptop, so when they leave it on the plane or the cab.
So it depends on the application. So it's up to the application to say user presence is fine. Well, it's up to the application to say, I don't really care, just give me the public key, or give me the proof of possession of the private key. Or I want to know that somebody's present, which is just the tap, or I want a second factor, which could be a PIN or a thumbprint or whatever. So it depends. FIDO will accommodate all of those scenarios. It really depends on the application's configuration as to what they request. So with FIDO 2 and the new WebAuthN and CTAP standards, and OpenID Connect making web authentication and single sign-on easy to implement, we've now got two prongs in this attack to get rid of passwords in general and to make authentication easier for users. Obviously, implementing this across an enterprise is a project. It's nothing that you're just going to buy and plug in. But as a strategy, focusing on OpenID Connect as an authentication scheme, which is, of course, what Azure AD uses, and FIDO 2 as a way of getting rid of passwords, I think is a really good strategy for getting rid of passwords in your environment and hopefully reducing the number of compromised credentials. So there's some other things to consider about WebAuthN and FIDO. So one is, what if I lose the token or phone? If all the application, this goes to your question, is if all the application cares about is that there's a user there, someone could potentially use that phone, but everybody's phone has a lock on it these days, so you'd have to get past that. And if the application requests a second factor, like another PIN or thumbprint or any kind of biometric, then that problem is pretty mitigated. The problem is that if you have to replace the phone, you basically have to go through the registration process with all of the applications again. Now, if you're using an identity provider that supports SAML and OpenID Connect, then hopefully there's only a few of those that you have to worry about. It's not hundreds and hundreds, but you do have to re-register them. Another one is, what if you want to get rid of your credentials? Let's say you've got credentials on your device for websites you just don't want to deal with anymore and you want to get rid of them. The device itself doesn't have a way to do that, but most devices will come with some application for managing the credentials that are stored on it. So you can put in the key or do it on your phone and say, delete this credential, delete that credential, and so on, and go through the registration process again if you need to. And this is the next one here is another question which I have not explored yet, which is what happens if the application actually changes domains? So I've implemented it under one domain name and now I'm moving it to another domain for whatever reason. Because the domain name is actually part of the relying party identifier, that now means that all those credentials are invalid. So your users will have to go through all that registration process again. And I don't think there's a way around that. There's another issue which is in the WebAuthN standard. There have been a few papers written about some marginal cryptographic processes in the standard. Now, I'm not a crypto guy, so I can't really comment in detail on that. I can give you some information that I dug up, and I can point you to the right papers. But the OpenID Connect problem with bearer tokens. So are you familiar with the idea of a bearer token? Is that something you're familiar with? So the idea of a bearer token is that it's a representation of an authorization or an authentication that is not tied to a particular session. It can be used anywhere. So Kerberos tickets, for instance, are generally bearer tokens. If I can take a bearer token from one machine and go use it somewhere else and still get the same effect. So bearer tokens are inherently insecure in that they can be stolen and reused elsewhere. And there's mitigation for that too. So on the crypto issues in FIDO 2, that's the Paragon Initiative blog that detail out the issues pretty well. It's really just for implementers of guys who are making these devices, not so much software writers who are writing websites. My reading of it is that it's not a big deal, because I think the hardware providers are in fact not using the older standards. But it's something it's useful to understand. As far as bearer tokens are concerned, this is inherent in OAuth and OAuth 2 and OpenID Connect. The problem is you can take a bearer token and use it anywhere, which means if you can somehow harvest a bearer token from a browser, or it might be in a browser store, or it might be off the network, you can then potentially reuse it somewhere else in the environment. There's a set of RFCs collectively called token binding, which provides some additional capabilities to applications to tie those bearer tokens to a TLS session. So it makes them basically so that even if you did steal them, you couldn't use them anywhere else. It requires support in the browser, which the major browser vendors, except for maybe Apple, have. But back in October, Google said that they were going to drop their support for it in Chrome, which was a bit of a shock, and everybody in the because they were in the group that developed the RFC, so it was a bit of a surprise. And the reasoning was it was just too expensive to maintain in the code base. I looked at the code and it didn't look that expensive to maintain to me, so I'm not quite sure where they're coming from on that. But Edge supports it, Mozilla supports it, and I think even Safari supports it now. But with Microsoft moving Edge to use the Chromium rendering engine, maybe this becomes a non-issue. I mean, Edge might become sufficiently good that everybody will tend to use it because it has the same rendering capability as Chrome, and it already has token binding support built into it. So we will see. It also requires support on the application end. Basically, you have to populate a header that says, I support token binding. And I believe Azure AD supports that now. The There are some scenarios that token binding doesn't mitigate. I mean, the fundamental problem is with bearer tokens is that it can be used anywhere.
Yeah.
And you know,
But
the
isn't that the utility of it also? I mean, I don't know.
yeah, I wouldn't say so much because binding it to a TLS session doesn't restrict. You know, these tokens are generally issued on a per application basis. So another example of bearer token is, or a token like this is just cookies. So web application cookies have the same problem. You can exfiltrate cookies from an application and use them elsewhere to potentially get privileges. So I don't think it inhibits the utility of it at all. I don't know. I have to think about that.
So what I'm wondering is TLS session's gone, now I need to verify.
Right, but in OpenID Connect and OAuth, you generally do refresh. You have to refresh your tokens anywhere it requires reauthentication. But it's actually tied to a TLS session, which is not just the TCP connection. So the TLS session's represented by shared keys on both sides of the connection. And even though the TCP connection goes away, when it comes back up, it'll use those keys again.
That's a good point.
Yeah, it doesn't renegotiate the TLS session every time. Okay, so other questions? Okay, so the question is if you've purchased a device that's using, say, some of the older RSA algorithms, how would you, and you then upgrade to more modern ECC type crypto, what would you do? Well, if the device itself was tied to RSA and that's all it knew how to do, then you'd have to replace the device. There's no way around that, I don't think. But all of the devices that come out today that I've seen are all use ECC and not RSA. I'm not actually aware of any of them that use RSA. So what Joe just mentioned is that TPM 1.2, if you've got those TPM devices in your machines, uses RSA crypto, and it's something that you would want to upgrade to TPM 2 to use ECC. Cool, all right, thank you very much.